Hello guys. Today we will see how to create Vellum hair growth and balloon inflate based on the noise Falloff. As you can see in the preview, the hairs and balloons have been growing and inflating based on the noise you can see here. So we will see how to achieve this in Houdini. So let's dive into Houdini. I have already imported the hand and camera for this. I have added the remesh since it was extremely highly detailed mesh. That's why. So now we will see how to achieve this effect. In this tutorial, I have used the mops node. So please install the mops package. It is free of cost, and let's start. So first today we ha- so first we have to use mops shape fall off node, and we have to press auto fit. This will fit the noise based on the bounding box of the hand. If you turn on click on auto fit and turn on preview, you can see the values have been uh, adjusted. Now you have to go on noise setting and click on noise, add noise, and here in the amplitude, increase the amplitude to around 26, yeah, 27, and you have to increase the frequency to around 1.8. Now increase the offset to around 1, and then we have to add a normal here, and then we will scatter some points. So first we will scatter points all over the hand, and then we will delete the points based on the length of the attribute. So first let's scatter around 18,500 points, and then take a attribute wrangle node, uh, attribute wrangle node, and here we have to write this. If we will use the length of the float attribute, and our float attribute will be this mobs fall off. So here type @mobs fall off is less than, we will create a channel name with threshold, and then we will remove the point. So in this way, if we click on the plus icon and increase this, it will delete the points which have the fall of attribute less than, no, greater than 0.366. So keep the keep this value to around 0.95, and now we will add an id attribute. We will use enumerate node to add the id attribute. Click on in the group type, select points, and here instead of index we will add id. And now we will again we will copy this attribute wrangle here, and since all the points are extremely close to each other, if we add a balloon, then each balloon will don't have enough space to inflate. so it will create issue and the simulation will get slow. To fix this, we will randomly delete the point based on the id attribute. So here instead of length we will use random function and we will use id, and here keep the value to zero point 0.6 or else 0.7. If you see, it have been deleted random points. Now we need to add p scale attribute. So to add that, we will take attribute randomized node, and the p scale minimum value will be zero point 0.5 and the maximum will be zero point 0.8. Since p scale is the float, uh, what we say here, we have to first write p scale. Since p scale is a float value, and here you can see it has been become 3 float. We have to change this dimension to single dimension, then it will have only one value. And here in the global scale we have to reduce the scale to 0.125. Now if we take a copy to point node and copy a sphere, here instead of the polygon mesh we have to choose a polygon and increase the frequency to zero point 0.6. Now you can see this in the initials only the pairs are intersecting to each other. To fix this we will use a fuse node and we will fuse it based on the p scale value. Since we have already set the p scale here, now if I add a fuse node and if I turn on this radius attribute, then you can see it the point which are in the radius of 0.125, it will get fused to each other. So it now we will have some uh, equally distributed points all over the surface. Now if you see, no spheres will get intersected between each other. If you increase this, then the radius will also get increased. So let's keep it around 1.25, and finally we have to add a rest node. We will save this position since we will use this after the simulation to scale the uh, simulation based on the noise follow. So here if you notice, if I template view the hand, you can see these spears have been uh, what we say goes inside the hand. So to fix this, what we can do is we can take a match size node, and in the z axis we can uh, set the value to a minimum. Now you can see the all of the hands, all of the balls have been come and stick around to its hand surface. So in this way you can avoid the intersection between the surface and the balls. Now the last thing is, if you will add some texture on this, then we will require some UV. So take a UV texture node and add it here. Instead of orthographic, we will choose polar and we will turn on fixed boundary. You can see if fixed boundary is turn off, then it will have some wrong UVs, and if we turn on this, then it will quickly fix it, but not too much accurate. So like this. Now we have to delete the attributes first. So here we will delete the id attribute and mobs a fall off attribute. So delete id and mobs fall off. Now we need two groups. First, let's take a group create node. This will be our balls. Name this as balls and set the group type to points. Now take another group create node, and here we have to connect the second input to remesh node. Here what we will do, and first set the name to pin and group type to points, turn off base group and turn on keep in bounding region. In this bounding type we have to choose bounding object. So now you can see few points have been added in the group, but for the few sphere uh, it have not been added in the group. If any of the spheres have remain unaffected, then the ball will get fall down due to the gravity. So what to avoid this, we can use a peak node and increase the peak distance to 0.01. Then all the points will get, all the spheres bottom part will get selected into the pin groups. Then we will pin this group in the Vellum solver. Now we have to take our attribute wrangle node, and here in the group we have to choose pin, and we have to write this simple code: I at the rate disable external is equal to 1. So what this code will do, whichever points which are present in the pin group, it will not get affected with the collision. If we remove this, then all the points will have some minor impact due to the collision, which will cause some jittery moment in the simulation. So we can also add I at the rate disable self is, is equal to 1. Where this code will also make sure that the pin groups will not collide with the other part of this pair, so which will be like disable self interaction. So now we can take a Vellum configure balloon node, and here in the cloth properties, first we can, let's see the edge length scale, and the thickness is okay. We can decrease this stiffness to 10 by, and here we will keep 7, and let's decrease the bend stiffness also to 0.01. And here in the pin points we will add our pin group, and in the pressure everything will be same. Here we will keep the pressure to 10,000 and the stiffness value to 5, and make sure to turn on this output group, and here instead of stretch let's write pressure, and we will take a vellum pack node and pack it. Now we will create the heads. Let's make it little bit dark. Now we will create the heads. So to create head, what we can do, uh, we can copy this all the nodes here and add it here, but instead of less than, we will keep greater than here. So we will have the opposite, what we say, color nodes, and keep the value, the threshold value to 0.9. And here in the random deletion, we'll keep the same value. Now we will take a rest node and we will add a rest position. Now we have to grow the hairs on this point. So to grow the hairs, you can simply take a copy to point and copy some lines, but I'm going to use this Vex code which is provided by default in Houdini. Uh, Take a attribute wrangle, and here in the Vex expression you can see this drop down arrow. If you click on that, and you can see here grow hairs. If you click here, then it will grow hairs. But currently the direction is set to y-axis. We can You can see the third line, it is saying grow in normal direction, but this line have been uh, a comment out. So if we remove this double forward slash, then it will grow the hairs based on the normal direction. But here you can see the hairs length are too big. We can decrease the length to around 0.08. But now the what jitter is too much. We can reduce the jitter value to around 0.0001. So you can see this. Now we have a nice clean heads. Now we have to add the first point of the primitive into the root group so that we can pin that group uh, in the Vellum constraint. So to do that, take a group expression node, and here in the group name we have to write root, and in the group type select point. In the Vex expression, click on the arrow and choose first point of the primitive. Now you can see the first point of the primitive have been added in the root group. Now we have to copy this triangle and paste it here. Instead of pin, we will choose root group. Now again take a group create node and select point. In the group type select point, and the group name we have to type here. So now what we need to do is we have to again delete the id attribute and the mobs Falloff attribute. So copy this attribute delete node and add it here. Now you can see this. We don't have mobs attribute and the id attribute. Now let's add a Vellum here, configure here. We will keep everything default in this node, and here in the pinpoint we can choose root group, and instead of stretch we will use here. In output group we will choose here, and everything is we will keep default. Now take a Vellum pack and pack it. We will merge both of this, and then we will take a Vellum uh, unpack node, and then we will add a Vellum solver here. So if I preview this, you can see the balls are falling down. It is happening due to the gravity force. Let's reduce this to 0. Turn off built-in bend and increase the velocity damping to 0.1. And now we have to create a noise of growth fall off. To do this, we will again take a mobs shape fall off node, mobs shape fall off, and we will connect this into the first output of the Vellum unpack. Here again we have to click on auto fit, and now if we turn on preview, you can see our fall off looks like this. Now we need to animate it. First we will drag this to a 0 totally, and we will add a keyframe to the translate. I will add the keyframe on the 24th frame, and the second keyframe will be on 72. On the 72, it will go still here like this, yeah. Now we have to go in noise parameter and click on add noise and increase the amplitude to around 10. So now you can see we will have something like this. So let's offset the frequency and add some octave like this. So we will have something like this growth. Go in the remap tab and turn on fit. Now we have to add a attribute remap node here. We will keep the mobs fall off here, and we will adjust this value in few minutes. Let's keep the node name to fall off. And now if I preview this, first let's see only the ball parts. If the ball is working perfectly, then we will move to this head part. So dive inside it and take a Vellum constraint property node and turn on the group tab, and here we have to choose pressure constraint group. Now if we preview this, you can see there is not too much change. If we turn on rest length scale and increase the value to 1000, then you can see that balls are inflating, but it is inflating directly. We don't want this kind of inflation. So to fix this, we will keep the rest scale value to 1 only, and we will turn on the vex expression, and here we will write a simple code. First we have to go in the input tab, and here in the input we have to choose SOP, and then we have to copy this null node and go inside it and paste it here. Here in the first line we will first copy the point number into one variable, integer variable. So here we will type integer pt is equal to prim points. We have to choose prim points, not prim point. We have to choose prim point, open bracket, 0 comma at the rate prim number bracket close, and we will choose array here, and the point number will be 0. Now we have to copy our fall of attribute from here into one variable. Since we have given our sub path as a third input, so we will choose here float who is equal to, we will choose take point function, and we are using input 3 which will be 2, since this is 0 1 and 2. And here we will, now we will write 2, and we will here we need to add the attribute name which is mobs Falloff, and we already have calculated the point number here, so we will write pt here and close the bracket. Now since we have to increase the rest length scale, you can see the rest length scale parameter is rest scale. So we can simply type rest scale is equal to foo. Now if I preview this simulation and our follows start growing from 24, there is no change happening because our uh, this value is clamped between 0 0.1 only, 0 to 1, and our rest scale is already at 1. So what we can do is we can increase this output max to around 150. And now let's see how this looks. As you can see, the balls are inflating, but there is some problem. You can see all the balls are not getting inflated. It is because all the balls have some random stretch value. So to fix that, what we can do is we can duplicate this Vellum constraint node, and instead of pressure we can choose bend and stretch constraint, and here we will keep everything default except this value. Instead of foo, instead of using foo directly, we will fit that value into 0 and the maximum which we want. So right fit, we will use foo attribute, and we already know the minimum and maximum value of our uh, attribute. If you have confusion, then this is our minimum value and this is our maximum value. So we will write 0 here, then 150, then 1. We will clamp a 0 value to 1 and 150 to 2.5, and we will close that bracket. Now if I play this, you can see our all balls will get inflated. As you can see, our all our balls are getting inflated. So our ball part is completed. You can preview this by turning on the hand visualization also. You can see it is growing like this. Now we have to work on the hair part. So let's remove this and turn on the merge node, dive inside it. Now again we have to do the same thing. We can also add the hair constraint here also, but I want some separate control, so I will duplicate this, and instead of bend and stretch I will choose hair, and the maximum hair growth will be defined here. So 2.5 is literally too big. I will keep it around 1.75. Now if I play this, you can see the hairs getting grow, but it is extremely less. So to fix this, what we can do is in here Vellum stretch. Uh, Anyways, let's keep this only as 3. I think 3 will be a good number. We can also increase it little more, like 8. 8 is too big. Let's keep it around 5 only. It is, I think. Uh, let's keep it 5 only. Now the problem is, you can see the heads don't have any wind or gravity. We can use pop force, and here we will choose hair group and add the now gravity here. Now you can see our hair will be like something like this. Now we will add wind force also, pop wind. Again hair group will give hair on the X direction, so our hairs will look something like this. Although you can adjust this value according to your need, so I will keep everything default only. Now what we have to add this also, and we need to add wind on the balls also. So instead of here we will duplicate the pop wind, and in the group we will choose ball balls, and the wind will be 0 0.5 and amplitude will be 0 0.3. Now if we will preview this, you can see it will look something like this. So it is looking like this currently. Now our simulation part is done, but we need to add one last thing in the DOP network, which is our mobs falloff attribute. We need to copy this attribute on this Vellum constraint. So to do this, we will take a geometry wrangle node, and here if you see go in any one of the constraint property node, you can see the geometry is set to constraint geometry. We will copy this, and in the geometry wrangle we will go in the data binding tab, and we will paste that value here. and we will again go, and we will go to input tab. In the input one, it is set to myself, and in the input 2 it is set as dop data, and dop data is object id. We will copy that. We will go in input tab of the geometry rectangle. In the input 1 we will choose myself. In the input 2 we will choose dop data, and we will paste that data here. And the input 3, again we have to choose sub path, and we will copy this path from here. We will paste it here, and again we will copy this whole value and paste it in the code. Instead of a rest scale, we will choose here foo, and we don't need to fit this value. We will keep it default so that we can change the scale value after the simulation as well. So we will keep this like foo is equal to this foo. So that's it for the Vellum solver. We will cast using Vellum IO node. Let's plug it in, and we have to give collision as well. So we will give the collision here. Although you can increase the substeps or constraint iteration, but for now I will keep it to one only, and then I will cast this to Dix. Like I will keep the name as ball. There is some problem, guys. I forgot to change this run over type to primitive, because all the attributes which are happening, we have to keep that on primitive level, not on the point level. So turn this to switch this value to primitive and cast it again. Now if I go here and choose full attribute, then I have the attribute. As you can see here, it is growing. So currently that attribute is on primitive level, so I have to add attribute promote node, and here we will choose original class as primitive, and we will choose foo, and then we will choose attribute transfer node, and click this here and this here. We'll copy the foo only. Now you can see it is like this. Now the last thing will be our scaling part, post scaling part. So first we need to take attribute remap node, and we will choose foo here, and we will compute the range. Since this range is not correct, we know our original range, which is 0 and 150. We will clamp that value in 0 to 1. Then we will take attribute warp node, and we will do the post scaling here. So to do the post scale, we will use make transform node, and this required for main input, which is rotation, translation, pivot, and scale. So for translation and rotation, we will use constant node, constant, and here in the constant type we will choose vector. Since this is a vector input, we will keep that value 0, 0 only. We will duplicate this and connect that into rotation, And here in the scale we will use our foo attribute. So we will use a bind here and we will choose foo. But you can see this scale is a vector component, but our foo is a float component. So if we connect this in directly here, then only the x, since vector have three direction x, y, and z. If we connect directly this into scale, then only the x direction will get the full value, not the y and z. So to fix that, we can choose vector to float node. We can add vector to float and connect all this parameter into x, y, and z, and then we will feed that value in the scale. Now here in the pivot, we will another take a bind node and we will call out our rest attribute, and the rest value is our vector attribute. So we will choose vector here, and then we will take a multiply node, connect this p into first input of the multiply x form into the second input, then the product will be our final p. Now you can see this is growing like this. This will go like this. So what is the use of this rest attribute? Since we have added the rest on the point, and this point will behave like a pivot, and the scale will happen from this pivot. That's why we save this attribute before adding spare onto the points. Now if you need more scale, then you can go in the attribute remap and you can increase this value or decrease it. It is up to you how you want to play. So then you can take a split node and split the heads here, and then you can add a sweep node. Instead of cross section, we will choose round tube. Let's increase the anti-aliasing samples and increase the radius to around uh, 12. 12 will be fine. And here in the end cap, you have to choose grid, and let's keep the end cap scale to 0.131, so you will have a smooth ending like this. And now you will have something like this cool effect. Then you can merge both of this, and you can also merge the hand here, and add a color node. This our head will be red, ball will be green color. So now it will look something like this. You can increase the hair quantity by adding more points here, then just re-simulate it. All things will get work automatically, because this is the procedural way to grow hairs on anything. So thank you guys for watching. If you like this tutorial, make sure to hit the like and subscribe button. Also you can support me on Patreon.